Good morning, guys. It's time to get started with math. Now, in order to practice mathematics, we're actually going to do a little bit of computer programming so that you can learn something new and have a different way of seeing the learning expectations over the summertime. When you go into the first math lesson, you're going to see a link to Python Programming Online. And when you click on it, it's going to take you to this web page, Replit Languages Python Turtle. And as we work our way through this lesson, we're going to cover the learning goals outlined in the Ontario curriculum of drawing a line through code and right-angle triangles. So if you just go ahead and click on the Python Programming Online link, it'll take you here. And what you're asked to do is to enter the following code, and that code's going to go in this box that's entitled main.py, and that py stands for Python. So you're going to type t is equal to turtle, and actually ahead of that you have to type import turtle. So it'll be import turtle, t is equal to turtle, and then t dot forward 40. And if you just go ahead and run those 3 lines by pressing the triangle here, you're going to see that it draws a line of length 40. Now, in terms of the units, these are in pixels. And what I'm going to ask you to do is think of these as millimeters. 40 millimeters is 4 centimeters. Now, depending on the size of your screen, this may or may not be exactly 4 centimeters. But the units that are used are a very small unit, a pixel. That's the little dots that light up on your computer screen. So we're going to think of them as millimeters. Then we're going to go t dot left 90. That's going to give us a 90-degree turn to the left. T dot forward 30. T dot left 127. And then finally t dot forward 50. And then the last couple of lines are really just to move the cursor out of the way. T dot pen up and t dot go to minus 100, 0. Now, you don't have to worry too much at this point what the first 2 lines do or the last 2 lines do. They need to be there, and we can talk about exactly what's happening with them later on. But for now, I want you to be concerned with all of these lines in the middle. I'm going to go ahead and run that. Remember, we run this by pressing the triangle here. And as you can see, this is drawn a right-angled triangle. The right angle is the 90-degree angle right here. And we have our first side length of 40 millimeters or 4 centimeters. And then it's turning 90 degrees. And then we've got a side length of 30 millimeters or 3 centimeters. And then we're turning, and to come down here, we're going with a side length of 50 millimeters. That's our first right angle triangle. Now, the next thing that you're being asked to do is change these numbers in here. I'm going to erase them all and do the whole thing from the beginning, just so you can get familiar with that. If you choose to change the numbers in there, that's fine. And so for the second lesson that's sort of outlined in your D2L, we're going to go forward 100, so that'll be 10 centimeters or 100 millimeters. Turn 90, forward 150, turn 147. Then we have to guess the length of that third side. And that's the point of our lessons this week. You're going to learn the Pythagorean Theorem, which is a way of calculating that third length. So let's just go ahead and give this a try. So we're going to import turtle, t equals turtle, t dot forward 100. That's going to be 100 millimeters or 10 centimeters. T dot left 90. T dot forward 150. T dot left 146. And then I left out the length of this last part here. So I'm making you guess. Now, from reading the code, that first line means our bottom line here is going to be 100 millimeters or 10 centimeters. And then this is going to be 15 centimeters or 150 millimeters. And now we've got to figure out the length of this side here. Now, let's try 150, just sort of for argument's sake, and see what happens. So I'm going to go ahead and run that. And notice 150 is not quite enough. The reason why is this is what we call the hypotenuse of a right-angled triangle. A right-angled triangle has an angle that's 90 degrees. That's this one down here. And the side length that is across from the 90 degrees is always going to be the longest side. So here I tried 150, but we already have a side that's 150. The longest side must be longer than 150. Okay, maybe we could try adding them together. So we have a side that's 100 millimeters and another side that's 150 millimeters. So let's try and make that third side 250 millimeters and see what happens. Now see how that's too long? This is an important idea in math. It's called the triangular inequality. And that means with a right-angled triangle, well, any triangle in fact, the third side cannot be greater than the sum of the two other sides. So what we found out is we need a number that is greater than 150, and that's less than 250. And at this point, I would like you to guess and keep trying different numbers until you can get that triangle to perfectly line up. That's the process we're going to use today to figure out how to find the third side of a right-angled triangle. On the next lesson, we're going to use the Pythagorean Theorem. We're going to have to practice a bit with square numbers and square roots before we do that, and you're going to learn precisely how to calculate that third side. So I'm not going to give the answer away here. I'll let you figure that out for yourself, and I just want to outline how to do the practice questions. So the first practice question is saying you are to, and these are the questions you're going to hand in so I can see how you're doing. You're to draw a right-angled triangle with side length of 9 centimeters, turn left 90 degrees, a side length of 5 centimeters, turn left 118 degrees, and then figure out how far to continue to complete the triangle. So let me show you how to do that without giving away the answer. So again, you'll go import turtle, t equals turtle, and then you're going to go forward 9 centimeters. Now remember, 9 centimeters is 90 millimeters. 90 millimeters will give you 9 centimeters. Then we turn left 90 degrees. Then to get 5 centimeters, we'll actually go forward 50. 50 millimeters is 5 centimeters. Then we're going to turn left 118 degrees. You see what's happening here is the angle is different depending on what the two side lengths are. Now to figure out how to calculate that angle, you'll actually learn to do that in grade 10. It's a pretty advanced topic. It's called trigonometry, something for you to look forward to. So we're not going to do that just yet, but I'm going to give you the angle or perhaps ask you to guess the angle in some of the questions to complete the triangle. Now we've got to go forward and we've got to figure out how long that last side is. So this code here is answering this question. Draw a right triangle with a side length of 9 centimeters, turn left 90, a side length of 5 centimeters, turn left 118, Then we got to figure out how far to continue to complete the triangle. So I've gone 9 centimeters, which is 90 millimeters. I've gone 5 centimeters, or 50 millimeters. I've turned left 118 degrees. Now, I'm pretty sure, as you've learned, 250 is going to be way too much. Our answer is going to be greater than 90 and less than 140. So let me just try 100. This is the only guess I'm going to take for you, and I'm going to let you take the guesses, changing this number to complete the triangle for each of them. And 100 brought us pretty close. So you're just going to have to play with that number, change it around until you can complete the triangle. Remember, for a couple of lines after, go T dot pen up. What that does is it'll move the cursor without drawing a line. And T dot go to minus 100 comma 0. So this is on a coordinate axis, and it's going to move the cursor over here so it's out of your way so you can fully see the triangle you've drawn. At this point, I'd like you to complete all of those practice questions as outlined in D2L. And then when you're done, if you could, copy the code that you've written. So we'll copy that. And then you can paste it into a Word document, or paste it in the Dropbox under the text section of D2L. And then I would like you to hand that in. So we could go, this could be practice question 1. Practice question 1, and save that, and then put that in the Dropbox for the lessons on July the 7th.